Welcome back, everybody. This is 8th grade algebra, Unit 9, Lesson 5. We'll be asking two questions today. One, how good is my line? And two, what is this R I keep hearing so much about? So previously, we did a few things with lines of best fit. First, we made them. We just sketched lines of best fit and said, well, it looks like the data is more or less going this direction. Then we asked ourselves, how much do we trust our predictions? And we learned to be a little bit skeptical of our own predictions based on several factors. How much data are we looking at? How closely does the line match the data? How far out into the future are we projecting? And so on. Today we're going to really dive into the question of how closely the line fits the data. So we're going to look at how closely related the two variables are and how we know mathematically. You're going to learn some terms such as correlation coefficient. You're going to learn to use the terms strong, weak, positive, or negative correlation. And you're going to learn what residuals are, which is the basis on which we do all the calculations, to figure out which of the lines is actually the line of best fit. Not just the line of good fit, but the best one. I'm going to quickly walk you through how we describe types of correlations, strong or weak, positive or negative, linear or nonlinear. And then you're going to do a think about it. You're going to have some discussions. You're going to learn what residuals are. And you're going to do an exit ticket. Now, what you don't see in this agenda is you'll be spending most of your time today playing around with statistics and trying to figure out what's going on with these lines. It should be fun. Okay, so here's how we describe correlations. One is that we have positive correlations. That means that as one variable goes up, so does the other variable. In this case, the hours you spend studying go up, your grade point average goes up. Not necessarily because of the hours you spend studying. We're not saying that it causes it, maybe. We're just saying that as one variable goes up, so does the other one. You also have negative correlations. Here we have the hours spent sleeping versus your stress level. So in general, there's a negative correlation, meaning as your hours spent sleeping go up, your stress level goes down. Or as your stress level goes up, your hours spent sleeping go down. We don't know which one causes the other or not, and we're not concerned with that today. We just want to know what happens when one variable goes up. Sometimes we have no correlation. Like this, you can't really draw a line and say, well, as one goes up, the other goes up. As one goes up, the other goes down. We don't know. There's no correlation here between hours spent sleeping and the number of pairs of shoes that you own. No relation. We also have linear or nonlinear correlations. So we can describe these in terms of, could it be fit by a line or would it be better fit by a curve? You'll see the first example here is best fit by a line. The second and third are best fit by curves. We also have a difference between a strong correlation and a weak correlation. Here we have two positive correlations. They look somewhat linear. The first one is strong because the dots are kind of clustered together. They'd be kind of close to the line, whereas the weaker version on the right, those dots are going to be farther away from the line. You see, the distance between the line and those dots is a lot bigger with the weak correlation. The strong correlation, they're really close to the line, meaning we can predict with a lot of accuracy based on our line of best fit. So here's a question for you. How would you describe the correlation between the two variables that are plotted here? Just think. You might have said that there's a negative correlation, meaning that as one of the variables goes up, the other one goes down. You could also say that the line going through these would have a negative slope. You also see that there's a weak correlation. It wouldn't be very close to that line. So there would be some dots that would be very far from the line. Those data points would not be well predicted by the line. So that's why it's a weak correlation. You also probably noticed it's more or less a linear correlation, meaning that you would draw a line, you wouldn't draw, say, a parabola through these. All right, I can't wait to hear what you learn about from today. One of the things I'm excited about is you getting to know when you can trust a scientific study and when you should be more skeptical of scientific studies. That's something I think is going to help you navigate the world and make sense of all the information that's coming at you and be able to say, here are the studies that I trust, and here are the studies that don't say what people think they say. That's it. Have a good time. Learn a lot. I'll see you soon. Bye.